Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through the binomial distribution. So binomial distributions arise when you perform multiple independent Bernoulli trials. So I went through a Bernoulli trial in a previous video. So when I say that the trials need to be independent, that means the probability of success in each trial is the same. The probability of success does not change from trial to trial. So let's look at this example here where we can build up some intuition for the binomial distribution. So 4 cards randomly picked from a deck. I'm talking about a normal deck of 52, no jokers, and we pick them one after the other with replacement. What is the probability that exactly 2 of them are hearts? So firstly, we need this with replacement so we can satisfy the idea that the trials are independent. So picking the cards with replacement ensures that the probability of success does not change with each draw of the card. So each draw of the card is a Bernoulli trial. This is 4 Bernoulli trials. So each time you pick a card, you can either have success and pick a heart, or failure, which means you don't get a heart. Each trial involves 2 possible outcomes, heart or not heart. That's why it's a Bernoulli trial. And as I said, picking the cards with replacement ensures that each time I pick a card, the probability of picking hearts is a quarter. The probability of success, a quarter, does not change from trial to trial. So X, our random variable, is going to be the number of hearts we pick. So this here is shorthand way of saying that our random variable follows a binomial distribution. So the binomial distribution needs 2 parameters. There's 2 bits of information we need to perform calculations. We need to know n, the number of trials, which in this case was 4, and p, which is the probability of success in each trial. And as I said, the probability of success cannot change from trial to trial. So each time I pick a card, because it's with replacement, probability of hearts is a quarter. So let's now calculate the probability that exactly 2 of the 4 cards are hearts. So I could get hearts, and then 2 cards that are not hearts. That's what H dash means, not hearts. So probability I pick hearts is a quarter each time. The probability I do not pick a heart is 3 over 4. So because each trial is independent, the probability that all 4 of these happen, that I get hearts, then 2 not hearts, I can just multiply all of these together. So basically what I'm doing is I'm multiplying a quarter squared by 3/4 squared. Really, I'm multiplying by a quarter for each heart I get. So there are 2 hearts. So a quarter times by itself twice. And then I'm multiplying by 3/4 each time I do not get a heart. So there were 2 not hearts. So 3/4 times by itself twice. But this doesn't answer the question of exactly 2 of them are hearts, because there are other ways I could pick 2 hearts. You know, I could pick hearts and then not heart, and then a heart, and then not heart. I could have the first 2 cards being failures, not heart, and then the last 2 being hearts. So each of these, this one here and this one here, they would have the same probability of occurring. There are 2 hearts, so I have a quarter squared for the 2 hearts, times by 3/4 squared for the 2 cards that are not hearts. So all of these have the same probability of occurring. But there are still other ways that I could pick 2 hearts and 2 not hearts. So how can I come up with a quick way to calculate how many ways this can occur? How many ways I can get 2 hearts and 2 not hearts? Well, think of it like this. There's the 1st, 2nd, 3rd, 4th cards. So there are 4 cards, and I need to choose which 2 of those are hearts. So 4 choose 2 is actually 6. So there are 6 ways that I can pick 2 hearts and 2 not hearts. 6 of these types. So really, to answer the probability question, the probability exactly 2 are hearts, I'm going to take my 1/4 squared times 3/4 squared. That's the probability of each of these individual outcomes. And I'm just going to multiply it by 6. That's a quick way to do it. And so putting it in my calculator, I get 0.211. Just over 20% or a fifth is the chance that I'll get 2 hearts and 2 cards that are not hearts. It's so much simpler doing it this way. And this is going to form the basis for the formula for the binomial distribution. The number of ways the thing can happen times by probability of success. The power is the number of successes you want, times by the probability of failure, and the power here is the number of failures we want. So let's go through and develop the formula for binomial distribution. So this here is the formula for calculating the probability of x successes. Little x is the number of successes when x follows a binomial distribution. Again, n is the number of trials, p is the probability of success on each trials, and x is the number of successes that you want. So there's also some simple formula for the expected value and variance. So just remember, each trial must be identical and independent. The probability of success must be the same each time, and that's why the binomial distribution requires things to be done with replacement. All right, let's now say we're picking 10 cards from a deck with replacement each time. So we're going to let x equal the number of hearts picked. We're going to calculate the probability that I pick exactly 3 hearts, that I pick at least 2 hearts, and then we're going to calculate expected value and variance of x. So let's start with the probability of 3. We're going to calculate the probability that if you pick 10 cards with replacement, you will get exactly 3 hearts. So n, number of trials, is 10. I want 3 hearts. 3 is the number of successes. So I times by 1/4 the probability of picking a heart to the power of 3 times 3/4 to the power of 7. So what's actually going on here? Well, this is the probability you get 3 hearts. This is the probability you get 7 cards that are not hearts. And this is the number of ways that it can occur. The number of ways that you can pick 3 hearts. So you could get 3 hearts, then 7 not hearts, or 7 not hearts, then 3 hearts. 10 choose 3 is the total number of ways that you can get 3 hearts from picking 10 cards. So putting that on our calculator, we get about 0.2503. So there's about a 1 in 4 chance that you'll pick exactly 3 hearts. All right, so this one here is asking us to find the probability that you pick at least 2 hearts. So that's the probability you get 2 hearts or 3 hearts or 4 hearts, all the way up to 10 hearts. That would take forever to calculate. So instead, what we're going to do is we're going to find the probability that you get fewer than or equal to 1 heart and subtract from 1. That's going to be so much easier. So we're subtracting from 1 the probability that you get no hearts plus the probability that you get 1 heart. And that will leave the probability you get 2 or more hearts. So to calculate the probability you get no hearts, we would use this formula here. N is still 10, but now the number of successes would be 0. So 10 choose 0, 1/4 to the power of 0, 3/4 to the power of 10. And that gives us about 0.0563. So the probability that you get exactly 1 head, well, that would be 10 choose 1, still 10 trials, 10 choose 1, 1/4 to the power of 1 times 3/4 to the power of 9, because I want 1 heart and 9 not hearts. And for that, we get about 0.1877. So what I'm going to do is add up these two numbers and subtract from 1. And so we get about 0.756. So there's about a 76% chance that you will get at least 2 heads. All right, let's look at calculating the expected value and the variance. Well, the expected value really makes sense. It's just NP, the number of trials times the probability of success. So here, I have 10 trials, and I would expect on 1/4 of those trials that I would pick a heart. So I would just expect to get 1/4 of 10, of means times, of those trials would give me hearts. So I expect to get hearts 2.5 times. Again, that's not actually possible. Of course, I can't get 2.5 hearts, but if I did this experiment where I draw 10 cards, if I did that over and over and over again, on average, I would expect 2.5 hearts. So the variance is easy as well. Just following the formula, it's NP times 1 minus P. So N here is 10. P, the probability of success was 1/4. 1 minus P, the probability of failure is 3/4. So that gives us 30 over 16 or 1.875. That is the variance. If I wanted the standard deviation, I would just square root that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.